Welcome to this video on simplifying simple surd expressions. Okay, we've got 4 of them here and we've got to simplify them and write them in the form a root b, where a and b are integers to be found. Okay, I've given a list of the square numbers here, the first 8 square numbers. Okay, you need to be familiar with those and know how they are useful in solving these problems. Okay, so we're going to start by just exploring the possible ways we could write root 80, for example. So the first thing you can do is you can split the 80 up into any pair of factors, like 8 and 10. So you could write root 80 as root 8, root 10. Okay, or you could write it as root 40, root 2. Okay, I'll just write some of these examples down. So we could say it's the same as root 2 times root 40, for example. Okay, now that may be true, but it's of no use to us in solving this problem. Okay, because root 2 and root 40 are both what we call irrational numbers. Okay, now what we do is we start looking for square numbers that are factors of 80, and we're looking for the largest one. Well, let's just go along the list and we say, well, 4 is a factor of 80, so you can write root 80 as root 4 times root 20. Okay, that's perfectly true, and it is. And then you say, well, root 4 is 2, so that can be written as 2 root 20, which is true. Okay, it is 2 root 20. And then you look at this and say, well, I've solved the problem, because it's written in the form a root b, and a is 2 and b is 20. Great, job done. Except that it isn't, because what you haven't done is simplified it fully. Okay, so that's not actually the answer, so we'll take that away because we've got to find the answer. All right, now what I should have done is looked at root 80, looked at my list of square numbers and looked for the largest square number that is a factor of 80, and I would have noticed that it's actually 16. Okay, 16 goes into 85 times, so instead of root 4 root 20, I should have looked at root 16 root 5, okay, because that will then give me a different looking answer. Although it's mathematically the same as this, it will actually be 4 root 5, and that's the correct answer because it's simplified fully. Okay, so that's the correct answer. And that could have come from this if you'd carried on. So if I had chosen to carry on with this, I could have written that next as 2 times, instead of root 20, I could have written root 4 root 5, you see, root 4 root 5. And root 4 root 5 is the same as 2 root 5. So I could have written it as 2 lots of 2 root 5, and that would have been the same as 4 root 5. So I would have got the answer eventually if I'd carried on working on that. Okay, so it's not wrong to go down that route, but you have to make sure you finish. So what is a fully simplified surd then? What are we actually aiming to achieve? Because that and that both are in the form a root b. Well, it's simply this. We're looking to find the largest possible number outside the square root and the smallest possible number inside the square root. Okay, and that's what we've done here. All right. Okay, the second one, 4 root 27. Leave the 4 alone. Look at the root 27. And notice that root 27 is the same as root 3 root 9. So this one is equal to 4 times, in brackets, root 9 root 3 okay? And root 9, because 9 is one of our square numbers, is 3. So it's 4 times 3 times root 3. So it's 4 lots of 3 root 3. Okay, and of course that is 12 root 3. All right, and that's quite a straightforward one to do. Again, recognizing and looking for the highest factor of 27 that was also a square number. Now, be very careful with addition and subtraction. You cannot simply take 54 from 150 to give you a 96 and find the root of 96. That is not how you solve these problems. Okay, you have to work on each one separately. Now, if I just look at the 150 under the first square root, I'm looking for a square number that's a factor of 150. Okay, well, the first one there is 25. Okay, 25 goes into 150 6 times. So what I'm going to do is I'm going to write this as root 25. Okay, so this whole thing here becomes root 25 okay, times root 6. Okay, that's the 150, the root 150. Okay, and then I've got to take away, and root 54, well, that comes from 6 nines of 54. Okay, so that comes from root 9 times root 6. Okay, and now we have two surd expressions, or terms rather, which contain the root of a square number. So the root 25 is 5. So this is equal to 5 root 6. Okay. And this bit here is equal to 3 root 6. So it's 5 root 6 minus 3 root 6. Well, 5 root 6 minus 3 root 6 is 2 root 6. And that would be the answer in the form A root B. Okay. And finally, we have root 15, root 12. Now, you could combine the two to make root 180, okay? I wouldn't necessarily recommend that, because if you've got two large numbers under square root signs, you multiply them together, you get a much larger number. You may not know how to work with that number, okay? It may be better to work on each bit individually. So I'm looking quickly at this and saying, well, I've got a root 15 which I can't simplify because the factors of 15 are 5 and 3. None of those are square numbers, but the root 12 does. So my thoughts on this would be doing something like this. So I'm going to start by doing root 15. I'll just leave that where it is. Okay. But next to it, instead of writing root 12, I'm going to recognize root 12 as root 4 times root 3, okay, which is, of course, the same as 2 root 3. So I've got root 15 times 2 times root 3, okay. So I've got 2 times root 3 times root 15, okay. I'm just doing it that way round because we tend to put the non-surd in front of the surd, okay. And then the root 3 and root 15, you might say, well, neither of those can be simplified, but actually if you combine them to make 2 root 45, okay, you might now notice that the root 45 can be broken up into root 9 and root 5, you see? So it becomes 2 root 9 root 5. And the 2 root 9 root 5, okay, the root 9 is 3. So that's actually 2 times 3 root 5. Okay, I'm really putting every step in at the moment just so you can see what's going on. Okay, you do need to show working for this to get all the marks, and 2 times 3 root 5 is 6 root 5. Okay, and that is the right answer. Okay, now another way that you could have got that from the beginning was to recognize that 15 times 12 is 180. So I'll do it this way as well, just so you can compare. Okay, I'll put it in a different color. So alternatively, I could have just gone straight to root 180, and you may find this easier. Okay, because 15 times 12 is 180. Okay, and that is, yeah, because 180 is root 36 root 5. Yeah, the highest square number, that factor of 180 is 36. So that's actually root 36 root 5. Okay, root 36 root 5. And of course root 36 is 6. So in fact you've got the answer quite quickly that way. Okay, but it does rely on you knowing your times tables and being able to recognize, in this case, that 36 was a factor of 180. Okay, so if you're good at your tables and you're confident with it, something like this could be quite quick. Okay, but either way, you've got to keep processing it until you've exhausted all the possibilities and you've looked for the highest common, the highest factor rather, that's a square number. Okay, so there's some information on surds, simplifying them and solving these kinds of problems where you're given an expression that isn't simplified and you've got to give it in the form a root b. One final thing, if this is a calculator paper, some calculators, in fact most of them now, will give you a simplified surd. If you put any of these in, you'll get the answer straight out. If the question is, say, 3 marks, and you just did that on the calculator, you wouldn't get any of the marks because you haven't spent any time on it or shown any understanding of it. You've just used the calculator. So you must show steps in your working, regardless of whether it's a calculator or non-calculator question. Okay, take care.